is a video Friday on 22. We're talking about radical properties. Day 3. For the new class today, the education use class, or you want to look over some stuff a little more. This video is for. We're going to be taking a look at two properties. These properties are radicals now. We're leaving the rational exponents behind, the fraction exponents behind a little bit, and we're going to focus just on radicals. And the property that we had yesterday, AB to the nth power, where A and B are both raised to the n power, same thing with division, that holds true with radicals as well, and that's what these two properties are. The product and quotient property for radicals says that if I'm taking the nth root of two things, I can take the nth root of A and the nth root of B separately. So it's showing here, if I'm taking the quotient one, the nth root of x over y, I can do the nth root of x separate from the nth root of y. They each get their own. It's really what this is talking about. Now, this can be used in a couple different ways. I can first use it, as in the example here, if I have two cubed roots, they have to have the same index. So that looks a lot like this. It says that I can combine them into one. So these properties go both ways. If you have them in one, you can break it up into two, or if you have it in two parts, you can combine it into one, just like we talked about yesterday with the exponent rules. So the cubed root of 4 and the cubed root of 2, 4 times 2 is 8, the cubed root of 8 is 2. Same thing with division, 162 over 2. They're both fourth roots, so I can put them together. 162 divided by 2 is 81. Fourth root of 81 is 3. So let's start with using the property that direction first. In example 2, I have the cubed root of 12 times 18. Neither one of these are perfect cubes. You can see at the end of the notes, I have the list of perfect roots for you. Again, okay, the ones you need to know. Nowhere on this cubed root list do I see 12 or 18. Okay? But if I put those together using the property, the cubed root of 12 times 18, put them together, 216. 216 is on the list. Cubed root of 216 is 6. Same thing with division. 80 and 5 are not on the fourth root list. But if I divide those, put them together and divide them, 80 divided by 5 is 16. Fourth root of 16 is there. 2. Okay? Now how you use these, I didn't tell you what the answers were. I just wrote what the perfect ones are. Obviously, it goes in order. 2, 3, 4, 5, 6, blah, blah, blah. 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5. 2, 3, 4, 5. So we usually won't get this high. And 2 and 3. I threw in there. Okay? You need to know those. Now we're going to use those properties in the reverse direction. If I have a number like this, can I use that property to break it up into two parts? Ignore this for now. And what I have is the cubed root of 135. 135 is not on my list of perfect cubes. The list of perfect cubes goes like this. 135 is not on it. But we are going to break this down. Now, we've done this with square roots before a little bit. And here's the goal. Some of you know how to do this already. We're just going to do it with higher indexes now. Some of you have no clues. Let me break it down for you. What we're going to do is when you have a radical of any type, and you want to simplify it and break it down, you're going to break it up into two parts. One of those needs to be perfect. So I'm going to look for the factors of whatever this number is. One of the factors has to be perfect. Perfect square root, third root, fourth root, whatever it is that we're dealing with in this problem. So in this one, I'm dealing with the cubed root. Okay, 135 is not on the cubed root list, but is there something that goes into 135 that is? In other words, is there a factor of 135 that is on the perfect cube list? And the answer is 27. 27 times 5. Now, how did I know 27? Well, what you can do, it's not like this list is very long, and you know 125 doesn't go into 135, so just do 135 divided by 8. Nope, doesn't go in evenly. 135 divided by 27 on your calculator. Yes, it does go in. 27 times 5. So you're going to break it up into two parts. You're going to take the cubed root of 27 and the cubed root of 5. That's the property. I'm going to take these two factors and break them up into separate cubed roots. Same property we're using up here, just in reverse. So instead of putting them together, we're pulling them apart. Cubed root of 27 is 3, so that goes in front. Taking the cubed root of it, it's now out of the radical. It's broken free. You can only break free out of the radical if you're perfect. It's like jail. You can't get out of jail until you're perfect. Okay, that doesn't really work, but you get the idea. This breaks out. It's 3. Cubed root of 5, that's not perfect, so it's stuck inside still. The answer is 3 times the cubed root of 5, or we just say 3 cubed roots of 5. I threw another couple examples here. Square root of 150. That's not a perfect square, but there is a perfect square that goes into it. I can factor 150 up to 25 and 6. The square root of 25 becomes 5. It's perfect, so it breaks out. And the square root of 6 is not perfect. It stays inside. 5 square roots of 6. How about fourth root? Looking at the fourth root list. I see 81. Well, 810 is not on the list, but 81 is. Break 810 up into 81 times 10. Two factors. The fourth root of 81 is perfect. That becomes 3. Fourth root of 10 is not perfect. It stays trapped inside. Okay. So that's using those properties in both directions. We do have one more thing to get to, and that's about simplifying. And these are going to work out perfectly. We're going to deal with the ones that don't work out perfectly on Monday. We're going to do the perfect ones today. And I do have another property, and this property isn't really an official property. We've kind of already done it. In fact, this is what the property was a couple days ago. A to the m over n equals the nth root of a to the m. Well, I can use that in reverse to say that if I have something that's a radical, turn it back into a fraction exponent. And we're not going to do that, but I'm going to show you how that works. Turn it back into a fraction exponent. And what happens is, let's say I have like the fourth root of x to the 12th. Turn that into the fraction form. That would be x to the 12. And index is the denominator over 3. What are you doing with exponents? When you're dealing with radicals, the exponents get divided. M divided by n. 12 divided by 4. This ends up being x to the 3rd. So when I look at something like this, I have a couple different parts. And I have these here if you want to use their method. I kind of like my own. I have a cubed root of 64. And the cubed root of x to the, or y to the 6. And we'll break it up into two parts and treat the numbers separate from the variables. What's the cubed root of 64? 4. What's the cubed root of y to the 6th? When you're dealing with radicals, you divide exponents. 6 divided by 3 answers y squared. Then we come to this one. I have the fourth root. Okay, wait a second. I'm dividing exponents. So this would be x to the 4 divided by 4. Y to the 8 divided by 4. The exponent divided by the index. So 4 divided by 4 is x to the 1st. 8 divided by 4 is y squared. Done. Now down here they have an absolute value. That's just because this is an even. If it's an odd, you don't need it. If it's an even, you do. But I don't do too much with absolute value. If you don't have it, I'm not going to make a big deal out of it. Okay? And that's it. That's all you have to do. Now, these get harder, but we'll deal with that Monday. These should all work out perfectly. When you take a look at your homework, look at the top of the homework page. It tells you exactly which problems to do. You're not doing all of them, just the ones that are indicated.